we think we know our planet. From the peaks of mountains to the lights of cities visible from orbit, Earth feels mapped, measured, and understood. Open a textbook, glance at a globe, scroll through satellite images online, and the impression is clear. Nothing is left hidden. The continents are coloured neatly. The seas are painted in shades of blue, and every corner seems accounted for. But that image is misleading, because while we've spent centuries charting the lands, building histories, and probing the skies, we have neglected the greatest frontier of all, the ocean, covering over 70% of Earth's surface. The ocean isn't just the largest feature of our planet, it is the defining one. It dictates weather patterns, drives climate, feeds billions, and holds the history of life itself. And yet, for all our technology, for all our scientific curiosity, we have explored only a tiny fraction of it, roughly 5%. Pause on that number. Imagine a vast library, 100 rooms wide, each packed with shelves from floor to ceiling. Every shelf holds books filled with mysteries, knowledge, and stories older than humanity itself. Now imagine you've only peeked into 5 of those rooms. You've touched a few books, flipped through a handful of pages, and declared you understand the library. That's our relationship with the ocean. 95% of it, almost everything, is still unknown territory. And here's the part that unsettles even the most rational minds. The ocean is not passive. It's not a dusty archive waiting to be catalogued. It's alive. It's dynamic. It shifts, hides, swallows, and reveals on timescales far beyond our comprehension. What lies in that 95% is not just unknown, it's potentially terrifying. Because the ocean is both cradle and crypt. It birthed life and has extinguished it more than once. It holds beauty beyond imagination, but also forces of destruction strong enough to reshape continents. If there are secrets in those depths, and we know there are, they could redefine not just our history, but our future. We tell ourselves stories of progress, that human curiosity is relentless, that we've climbed Everest, mapped the human genome, walked on the moon. But beneath our feet, beneath the waves, there exists a kingdom larger than all the continents combined, and we've barely dipped our toes. We assume the land is where history happens, where civilizations rise and fall, where discovery takes place. Yet the truth is inverted. The land is the margin. The ocean is the page. But why? Why have we left this vast dominion uncharted? Part of the answer is simple. It's hard. The ocean resists us in ways space itself sometimes doesn't. Pressure that crushes steel, darkness thicker than night, cold so complete it drains the warmth from machines and flesh alike. Every meter deeper is another barrier to human exploration. And so, unlike mountains or deserts, which yield grudgingly to persistence, the ocean denies entry altogether. And yet, that resistance is only part of the story. The deeper reason we have left the ocean unexplored may be psychological. Humans fear what they cannot see. A forest at night is frightening. A cave unlit is intimidating. But the ocean, an abyss with no end, no light, no air, is the ultimate unknown. For centuries, sailors whispered of monsters, gods, and devils beneath the waves. Entire mythologies grew from the black water. Even today, in an age of satellites and submarines, that primal fear remains. We send drones, but rarely ourselves. We skim the surface and comfort ourselves with the illusion of mastery. Here's the unsettling truth. Ignorance is not safety. If anything, it is vulnerability. Because while we may not know what's down there knows us. Currents carry heat, storms gather power, quakes ripple from ocean trenches, and tsunamis strike with little warning. Creatures we barely understand drift into our nets, wash up on our beaches, or appear in our sonar scans for moments before vanishing again. Every year, discoveries remind us how little we know and hint at what still lurks unseen. We live as though the ocean is background, a blue stretch between nations, a space for shipping lanes and fishing grounds. But that's a delusion. The ocean's the planet, and we've only seen 5% of it. So the real question is not whether the remaining 95% holds secrets. The question is, when we finally dare to look, will we be ready for what we find? When people hear that only 5% of the ocean has been explored, the number almost feels unbelievable. We live in an era of GPS satellites, global shipping networks, deep-sea cables carrying the internet across continents. Surely, with all that technology, we must know far more. But the truth is, the ocean keeps its secrets well. What we call exploration is often just scratching the surface, literally. The majority of our so-called knowledge about the seafloor comes not from direct observation, but from remote sensing. Satellites can map the contours of the seafloor by measuring tiny changes in gravity, a method that provides a blurry, low-resolution outline. It's the difference between seeing a mountain range from space and actually hiking its valleys and cliffs. The broad strokes are there. Trenches, ridges, vast plains. But the details, every canyon, every vent, every cave, remain hidden. Even the technologies we've used to probe the deep, sonar mapping, remotely operated vehicles, ROVs, crewed submersibles, have touched only tiny pockets of the vast sea floor. We know more about the surface of the Moon and Mars than we do about the terrain beneath our own oceans. A spacecraft can orbit a planet and map its surface in months. Mapping the seafloor at that level of detail would take centuries. Why? The challenge begins with sheer size. The ocean covers nearly 361 million square kilometers. That's about 2/3 of the entire planet, and every square kilometre can plunge to depths measured in kilometres. The deepest trenches cut more than 11,000 metres into the earth, deeper than Everest is tall. At those depths, pressure builds to over 1,000 times what we feel at sea level. Sending machines there is possible. Sending humans is deadly. Then there is the problem of light, or rather, the absence of it. Sunlight fades within the first few hundred meters. Beyond that, the ocean becomes a world of perpetual night. Cameras need artificial lighting, but light only penetrates a few meters in the murk before scattering away. What we see is always a narrow cone surrounded by darkness. Imagine walking through a vast, pitch-black cathedral with a single flashlight beam. That's what ocean exploration feels like. Cold adds to the barrier. At depth, temperatures hover near freezing. Electronics seize, batteries drain, and materials weaken. Even our best machines fail under these conditions, leaving expensive wrecks at the bottom. Every dive is a gamble, and yet, despite all this, humans have managed glimpses. The submersibles of the mid-20th century gave us the first real looks at the abyss. In 1960, Jacques Piccard and Don Walsh descended into the Challenger Deep of the Mariana Trench, the deepest known point of Earth's ocean. Their tiny craft, the Trieste, took nearly 5 hours to sink, and when they reached the bottom, they could barely see through the swirling sediment their landing stirred up. They stayed for only 20 minutes before rising back to the surface. It was a monumental achievement, but it was also just one point in one trench, in one ocean. Decades later, James Cameron returned to Challenger Deep in 2012, this time with more advanced technology. Again, the feat made headlines. Again, it revealed how little we know. For all our triumphs, these dives are rare, expensive, and limited. Most of the ocean remains untouched by human eyes. What about life? The oceans teem with it, but our knowledge is laughably incomplete. The Census of Marine Life, a massive 10-year international project completed in 2010, catalogued more than 6,000 new species. And yet, scientists involved admitted this was barely scratching the surface. Some estimates suggest as many as 2/3 of all marine species remain undiscovered. Entire ecosystems could exist in places we've never visited. Consider hydrothermal vents, cracks in the seafloor where superheated water rich in minerals gushes out. We only discovered them in 1977, and when we did, the life surrounding them rewrote biology textbooks. Strange creatures thrived not on sunlight, but on chemical energy from the earth itself. Giant tube worms, clams with symbiotic bacteria, shrimp with reflective scales. Before that moment, no one had imagined such an ecosystem was possible. If something so alien could exist so close to us, what else is out there in the unvisited dark? And then there are the sounds. The ocean is filled with noises. Whales calling across thousands of kilometers, earthquakes rumbling, icebergs cracking apart. But some of the sounds recorded by hydrophones remain unexplained. The bloop, captured in 1997, was one of the loudest underwater sounds ever detected. Its origin is still debated. Many scientists attribute it to ice quakes, but its unusual characteristics keep speculation alive. If such mysteries can emerge from passive listening, what might we find if we actually looked? All of this raises a sobering point. When we say 5% explored, we don't mean we've thoroughly studied that fraction. We mean we've made brief visits, taken samples, mapped small areas, and moved on. The other 95% isn't just unseen, it's entirely unexamined. Why does this matter? Because the ocean doesn't simply sit there. It shapes the fate of continents and civilizations. Storms born in the tropics devastate coastlines. Tsunamis, generated by undersea earthquakes, destroy cities in hours. Currents regulate climate, carrying heat across the globe. To remain ignorant of the ocean is to remain ignorant of the system that sustains us. And yet, ignorance persists. Funding for deep-sea exploration lags far behind space programs. We spend billions to send probes to Mars, while the largest habitat on Earth remains unexplored. Perhaps it's because the ocean feels too close, too familiar. Or perhaps it's because, deep down, we sense that what we find there may not bring comfort, but dread. Because if the 5% we have seen holds creatures with glowing lures, transparent predators, forests of alien corals, and vents that boil water in pitch-black silence, what on earth could be hiding in the rest? When we imagine exploration, we picture footprints left behind, ruins buried in sand, fossils embedded in stone. On land, the past lingers. A broken shard of pottery can survive thousands of years. A temple wall can endure millennia if left undisturbed. Even ancient footprints, pressed into volcanic ash, have been preserved long enough for us to study them today. The ocean is different. It does not preserve. It erases. Every force that rules the deep conspires against memory. Pressure, current, chemistry, and geology combine to wipe away almost every trace of what once existed. This is one of the great reasons why we know so little, not only about present life in the ocean, but about its past. At the surface, we live under the weight of the atmosphere, about 1 kilogram per square centimetre. Descend into the deep, and that weight multiplies with each metre. By the time you reach 1,000 metres, the pressure is 100 times greater than what we feel at sea level. By 10,000 metres, in trenches like the Mariana, it's over 1,000 times greater. That pressure is relentless. It crushes air pockets, deforms metals, and obliterates anything fragile. Bones dissolve, wood splinters, even stone is ground down under shifting sediment. What could survive 100,000 years under such crushing weight? Almost nothing. On land, a ruin may be buried in sand or ash, where it waits for discovery. In the ocean, currents sweep continuously across the seabed, Sediments move like rivers, burying and uncovering, scattering and reshaping. Over centuries, entire features can vanish beneath thick layers of mud, only to be revealed again before being hidden once more. And these aren't calm, predictable flows. Deep currents can roar faster than rivers, carving canyons into the seabed and smothering entire ecosystems in moments. A fragile object, even one made of stone, can be rolled, battered, and broken down until it is indistinguishable from the natural environment. The ocean is a solvent. Salt water eats away at metal, turns iron to rust, bronze to powder. Wood swells, cracks, and rots. Fabrics disintegrate. Plastics, so persistent on land, eventually fracture under sunlight, currents, and microbial attack, breaking into microplastics invisible to the naked eye. Even bone, which fossilizes so well in dry conditions, dissolves rapidly in seawater. Ancient whales leave no skeletons for us to find. Their remains vanish into the chemistry of the deep. If the ocean can erase whales in a few centuries, what hope is there of finding more delicate traces of unknown creatures or human civilizations tens of thousands of years later? The Earth's crust beneath the ocean is not stable bedrock. It is a conveyor belt. New crust forms at mid-ocean ridges, where molten rock pushes upward, creating mountains and valleys. That crust then drifts outward until, at the edges of trenches, it sinks back into the mantle. Entire sections of seafloor are swallowed and destroyed in this process, taking everything on them into the Earth's interior. This means much of the ocean floor is younger than the continents. While land can preserve rocks billions of years old, the ocean floor rarely lasts more than 200 million years before being recycled. History, in other words, is constantly being erased. On land, a ruin may be slowly buried in soil, but in the ocean, life accelerates destruction. Bacteria consume organic material almost immediately. Barnacles, corals, and other encrusting organisms cover surfaces, transforming artifacts into reefs. Scavengers tear apart carcasses, sometimes within hours of death. Skeletons of massive whales have been recorded disappearing in less than a decade. The deep sea is not barren, it's ravenous, and it ensures little survives in recognizable form. Because of this erasure, what we do see at the bottom often looks empty. Expanses of mud, featureless plains, scattered rocks. It's easy to assume nothing ever lived there, nothing ever happened there. But that emptiness is an illusion created by time and decay. Just as an empty desert might once have been a lush forest, a flat seabed could once have hosted entire ecosystems or even human settlements, long since erased by currents and chemistry. It matters because it reshapes our expectations. When archaeologists say there is no evidence of an advanced society beneath the waves, they may be right. but only because the ocean is an expert at hiding its tracks. Just as erosion on land makes it nearly impossible to find traces of something from 100,000 years ago, the ocean makes it impossible to find traces from even 10,000. The deeper you go, the more complete the erasure. It's not just absence of evidence, it's deliberate obliteration by the planet itself. Imagine our own world ended tomorrow, cities abandoned, machines silenced. In 1,000 years, the forests would reclaim the land. In 10,000, most of our structures would crumble. Now imagine the same world submerged. Skyscrapers fall, rust and dissolve. Roads break apart. Concrete vanishes. Plastics fracture into dust. By 100,000 years, there would be nothing recognizable. By 1,000,000, the sea floor would have recycled itself. What would remain for future explorers? Almost nothing. So when we look at the ocean and declare it empty, unexplored but barren, we may be deceiving ourselves. The ocean doesn't show us its past, it buries it, which means if terrifying things once lurked there, colossal predators, lost worlds, civilizations swallowed by rising seas, we might never know. Unless, of course, we're lucky enough to stumble on the rare fragments that escape destruction. And that possibility is what keeps the question alive. If 95% of the ocean is unexplored and most evidence is erased, what could be hiding down there that has escaped our notice? When we talk about the unexplored ocean, it's easy to think in terms of empty space, dark water, barren plains, silence. But the truth is the opposite. The ocean is not empty, it's alive, unimaginably alive. The 5% we've explored has already revealed ecosystems so alien they might as well belong to another planet. If that's what we've seen in the slivers of darkness we've touched, then what waits in the remaining 95% could be beyond anything we dare to imagine. Start with what we already know. At depths where sunlight cannot reach, life glows. Bioluminescence, creatures making their own light, isn't rare. It's the rule. Squids that pulse blue like neon signs. Fish with lanterns hanging from their heads. Shrimp that fire jets of glowing chemicals like undersea flamethrowers. Even sharks that emit faint glows invisible to human eyes. A language of light in the abyss. These aren't isolated curiosities. Scientists estimate that as much as 80% of deep-sea species use bioluminescence in some form. Entire food webs run on light produced by life itself, a living galaxy in the darkness. And then there are the giants. The colossal squid, once a sailor's legend, is real and larger than we dared imagine. With eyes the size of dinner plates and tentacles lined with swiveling hooks, it hunts in depths no human has yet witnessed. The fact that such a monster remained hidden until only fragments washed ashore shows how much more could still be down there. We've found fish that look like nightmares, anglerfish with jaws unhinging wider than their bodies, gulper eels that balloon their stomachs to swallow prey larger than themselves, dragonfish with transparent fangs that shine with their own light. These are not rare exceptions. These are examples from the tiny slice of the ocean we have managed to study. If this is the 5%, what horrors, what wonders wait in the 95? Every 1,000 meters deeper is another threshold of impossibility. And yet, life continues to thrive. In trenches, where the pressure is over 1,000 times that at the surface, we have discovered ghostly snailfish with translucent skin and flexible bones, darting through cracks where no light and little food exists. How do they survive? We don't fully know. Now imagine an ecosystem adapted not just to survive pressure, but to exploit it. What if there are organisms whose very biology depends on crushing force? Life that would collapse if brought to the surface. Such creatures could thrive in entire worlds hidden from us, perfectly evolved for environments we cannot replicate. They might live their entire lives unseen, their existence betrayed only if one drifts too close to our instruments by accident. Hydrothermal vents showed us that sunlight is not necessary for life. Instead of photosynthesis, there is chemosynthesis, bacteria that feed on minerals and sulfur, forming the foundation of entire ecosystems. Towering black smokers pour superheated water into the cold deep, creating oases where shrimp, worms, and crabs thrive. If such complexity exists around vents we've stumbled upon, how many more ecosystems thrive around those we've never found? Mid-ocean ridges circle the globe like scars, thousands of kilometers long. Most of them are unexplored. Each could host entire communities as yet unseen, ecosystems that dwarf our imagination, with creatures evolved along paths we cannot predict. Not all the ocean's secrets are fiery. Some are frozen. Beneath Antarctica's ice shelves, scientists drilled through kilometers of ice and discovered fish, sponges, and organisms clinging to life in places thought utterly barren. Beneath the Black Sea, layers of anoxic water harbor microbial worlds unknown to science. These are hints of a greater truth. The ocean holds countless hidden habitats, shielded from view not just by depth, but by ice, chemistry, or geography. In the unexplored ocean, size itself becomes a mystery. On one hand, deep pressure and low energy could favor the rise of creatures of staggering size. The colossal squid may not be the limit. What if there are predators larger still, confined to trenches and rising only rarely? Legends of sea serpents, krakens, and leviathans might be exaggerations, but they may also be cultural echoes of real encounters with creatures glimpsed and not understood. On the other hand, the deep sea may harbor organisms so small and strange, we barely recognize them as life. microbes thriving inside rocks, miles beneath the seabed, extremophiles that feed on methane and hydrogen, colonies that grow slowly for centuries. The so-called deep biosphere is vast, perhaps containing more biomass than all surface life combined. If we have overlooked something so enormous, what else have we missed? Every ecosystem we know has predators, apex hunters. The ocean is no different. Sharks rule the surface and mid-depths. Squids and whales clash in the twilight zone. But what about the abyssal trenches? Who rules there? If evolution has taught us anything, it's that niches are filled. Wherever there is prey, there is a predator. And wherever there is energy, life adapts to consume it. In the untouched deep, beyond sonar and cameras, what apex hunters may wait? Perhaps creatures that sense vibrations across kilometers. Perhaps ambush predators that use pressure and darkness to their advantage. Perhaps beings so strange we would not recognize them as animals at all. Sometimes evidence comes not from sightings, but from mysteries. Enormous scars found on whales, wider than the tentacles of any known squid. Unexplained sonar returns showing massive shapes moving in the deep. Strange sounds recorded by hydrophones, too loud for any known creature. Each could have a mundane explanation, but each could also be a glimpse into the unknown. And then there is the fact that every year, scientists describe thousands of new marine species. Most are small, new fish, new corals, new crustaceans. But the discovery rate itself proves how incomplete our knowledge is. If in the shallower, more accessible zones, we are still finding surprises, what lies in the abyss, where almost nothing has been touched? And here we come to the most unsettling thought. We assume that intelligence is rare, that humans are unique, that dolphins and octopuses are the closest parallels. But what if, in the deep, something else evolved intelligence along a path invisible to us? Octopuses already show problem-solving, tool use, and even playfulness. Squids coordinate in groups. These are shallow water relatives of deep species we've barely glimpsed. Could the abyss hide lineages that went further, whose intelligence is hidden by the fact that they never leave the dark? Not civilizations, not cities of stone, but intelligence that is alien to us, built on senses and perceptions, shaped by crushing pressure and eternal night. If such beings exist, we may never find them, or worse, we may find them only when they find us. The idea of undiscovered monsters lurking in the deep may sound like myth, but remember, every discovery so far has been stranger than we expected. The giant squid was a legend until proof emerged. Hydrothermal vents were unimaginable until we found them. The glowing creatures of the abyss, once dismissed as sailors' tales, are now textbook examples of adaptation. Time and again, the ocean reveals that what we thought impossible is real. The most dramatic reminder of the ocean's power is the tsunami. These monster waves are not like ordinary surf. They are walls of water born from violence beneath the sea, earthquakes, landslides, even volcanic eruptions. When an earthquake ripped the seabed off the coast of Sumatra in 2004, it displaced billions of tons of water. Within hours, waves struck coastlines across the Indian Ocean, killing over 200,000 people. In 2011, an undersea quake off Japan triggered a tsunami that destroyed cities and crippled nuclear reactors. And those were just in the last 2 decades. The ocean floor is scarred with subduction zones, where one tectonic plate dives beneath another. These zones are time bombs. They build tension for centuries and then release it in minutes, unleashing quakes that shift the seafloor by meters. Every such shift has the potential to create tsunamis. The terrifying part? Most subduction zones lie in the unexplored deep. We map their outlines, but we don't know the details. Where stress is building, where cracks are forming, where the next rupture will happen. The 95% we haven't seen could be hiding the fault lines of tomorrow's disaster. Even without quakes, the ocean can turn violent. The seafloor is steep in many places, lined with cliffs and canyons larger than anything on land. These slopes are unstable. Sediment builds up until one day, without warning, it collapses. These underwater landslides displace water just like earthquakes do, generating tsunamis that strike coasts with no clear warning. The Storegga slide off Norway 8,000 years ago unleashed a wave tens of meters high that smashed into Scotland's shores. Entire populations could have been wiped out. And that was just one slide. How many more unstable slopes lie hidden in the unexplored ocean? How many more Storeggas are waiting? The land has volcanoes, but the ocean has more. In fact, most volcanic activity on Earth happens underwater. Mid-ocean ridges stretch around the planet like scars, constantly venting lava. Seamounts, undersea mountains, dot the deep by the tens of thousands, many still active. When an undersea volcano erupts, it can reshape entire landscapes. The eruption of Hunga Tonga Honga Ha'apai in 2022, though not fully submarine, blasted ash halfway to space and generated tsunamis across the Pacific. That was a minor reminder of what the ocean hides. The deep could hold super eruptions we have never seen, explosions large enough to trigger climate shifts, collapse ecosystems, or drown coastlines. The terrifying part is, we don't even know where most of these volcanoes are. The ocean doesn't just hold water, it holds gas. Beneath the seabed, locked in frozen crystals called methane hydrates, lies an enormous reservoir of methane, far more than is currently in the atmosphere. If destabilized, these hydrates can release their gas in sudden, violent bursts. Such an event could trigger explosions, landslides, or massive climate shifts. Some scientists suspect past extinction events were driven by sudden methane releases from the seafloor, turning the planet into a greenhouse in decades. We've seen small releases, methane bubbling up in the Arctic as warming seas destabilize hydrates. But the bulk of these reserves are in the unexplored ocean. We don't know where the largest deposits are, how stable they are, or what might trigger them. It's a loaded gun we've barely studied. More than 90% of Earth's earthquakes occur under the ocean. Some are small tremors, never felt on land. Others are monsters that reshape coastlines. Because the ocean floor is so poorly mapped, we often don't know where these quakes originate until after they strike. Imagine the land equivalent, living on a continent where most mountain ranges and fault lines were still unknown. That's where we are with the seafloor. We live at the mercy of forces we barely track, in landscapes we've never seen. Perhaps the most terrifying possibility is one we've only begun to consider. The ocean controls climate in ways we don't fully understand. Currents transport heat across the globe, creating stable weather systems that allow civilizations to flourish. But what if those currents change? Scientists warn of the possible collapse of the Atlantic Meridional Overturning Circulation, AMOC, the system that includes the Gulf Stream. If it weakens or shuts down, Europe could plunge into freezing winters while the tropics bake in heat. Agriculture could collapse. Entire regions could become unlivable. And yet, the mechanics of these currents are poorly understood, especially in the deep where cold, salty water sinks to drive the system. We don't know how stable it is. We don't know what thresholds exist. The unexplored ocean hides the switches that control the planet's thermostat. Mass extinctions have struck Earth multiple times. The dinosaurs fell to an asteroid, but other die-offs seem linked to the ocean. Anoxic events, when oxygen vanished from the seas, choked out life and left only microbes to thrive. Could such an event happen again? Absolutely. We already see dead zones spreading in modern oceans, fueled by warming and pollution. The deep could hold the clues to past collapses and the warnings for future ones, but we haven't looked deeply enough. We may be sailing blind into catastrophe. The ocean doesn't just hide creatures, it hides events. Eruptions, quakes, landslides, and chemical shifts all begin in places we haven't studied. Some are local, devastating only a coast. Others could reset the planet. The fact that we don't know which is which is terrifying. We treat the ocean like a backdrop, but it is the stage. The deep is where the great forces gather, and one day they will strike again. The only question is when, and whether we will see it coming. Long before sonar, satellites, or submarines, humanity tried to explain the ocean the only way it could, through stories. Sailors, fishers, and coastal peoples lived in constant contact with the sea. They watched it rise in storms, vanish in calms, and return in floods. They saw things, shadows beneath waves, glowing lights in the dark, monstrous shapes rising and sinking that defied explanation. The ocean was unknowable, so they gave it names: Kraken, Leviathan, sea serpents, Atlantis. For centuries, scholars dismissed these tales as superstition. But time and again, fragments of myth have revealed themselves to be echoes of reality. And if myths can hold truth, what might they tell us about the 95% of the ocean we have never seen? Sailors of the North Atlantic told of the Kraken, a beast so large it could drag ships beneath the waves. Its tentacles were said to stretch as wide as masts, its body the size of an island. For generations, it was a sailor's tale, until the 19th and 20th centuries, when fragments of colossal squids began washing ashore. Tentacles longer than a man, beaks large enough to snap bone. Then, in the 21st century, cameras finally captured living giant squids in the deep. Today, we know they exist. They are among the largest invertebrates on Earth. Still rarely seen, still poorly understood. What sailors described as kraken may well have been encounters with these creatures, or perhaps something even larger, something that remains hidden in the trenches. If such monsters lived unseen until just decades ago, who's to say greater beasts don't still patrol the abyss? In ancient texts, Leviathan was a creature of chaos, a sea dragon that embodied destruction. While we interpret it today as myth, the imagery resonates with something primal. Humans sense, even without science, that the sea hides powers greater than us. Some scholars argue Leviathan was inspired by real encounters with whales, giants that seem to rise from the deep, breathe fire-like spouts, and vanish again. Others suggest it may reflect even stranger sightings. When you live on fragile wooden ships, the ocean itself feels like a beast, always watching, always waiting. And perhaps that sense of dread was right. Leviathan may not be a literal monster, but a metaphor for the ocean itself. A force vast, terrifying, and ultimately unknowable. Plato's story of Atlantis describes a great civilization swallowed by the ocean in a single night. Most historians see it as allegory. Yet scattered across the world are stories of lands drowned by rising seas. Aboriginal Australians tell of coasts swallowed by the ocean thousands of years ago. In South Asia, Sanskrit texts describe kingdoms lost to floods. The biblical tale of Noah echoes older Mesopotamian myths of deluge. These may not be stories of one lost city, but of many. After the last ice age, sea levels rose by more than 100 meters, drowning millions of square kilometers of land. Entire coastlines, where humans once lived, now lie beneath waves, unexplored and unmapped. Could some of the ruins of early societies lie preserved there, mistaken for natural formations? Modern sonar has revealed curious shapes on the seafloor, grids, ridges, and terraces that some claim are ancient structures. Most are dismissed as geology, but the possibility lingers. If civilizations existed along ancient coasts, most of their remains would now lie underwater, hidden in that unexplored 95%. In 1997, hydrophones in the Pacific picked up a sound now known as the bloop. It was one of the loudest underwater noises ever recorded, far louder than the calls of blue whales. Its origin? Still debated. Some scientists attribute it to ice breaking in Antarctica, but others note its profile resembled that of a living creature. Since then, other unexplained sounds have been recorded. Julia, train, whistle, and more. Some were later tied to natural events, but others remain mysteries. If animals, they would represent creatures larger than any we know. If geology, they are processes we still don't understand. Either way, the message is the same. The ocean hides forces we cannot identify. From time to time, objects appear where they shouldn't. Reports of massive megaliths on the seafloor near Japan, unusual geometric structures in the Caribbean, artifacts pulled from deep sea dredges that resemble worked stone or metal. Most are dismissed as natural formations or modern contamination. Yet the stories persist. The truth is, the seafloor is largely unmapped. If an ancient ruin, a shipwreck older than history, or even an artifact from a forgotten society exists, it could be buried under silt, mistaken for geology, or simply ignored. With 95% unexplored, how can we be certain what isn't there? It's tempting to dismiss legends, but history warns us against arrogance. Once, stories of glowing seas were laughed at until bioluminescence was discovered. Once, tales of giant squid were mocked until science caught up. So when we hear of monsters, lost lands, and mysterious sounds, perhaps we should not dismiss them so quickly. Myths are not proof, but they are memory. They are whispers across generations of things glimpsed, half understood, and feared. And if myths echo reality, then the unexplored ocean may not just be a void waiting for discovery. It may be the stage for stories we have only begun to hear. We live on a planet of water. From space, Earth is not a green world or a brown one. It is blue. The ocean dominates the map, wraps around every continent, and dictates every climate. It feeds us, carries our ships, and fills our myths. And yet, we treat it like background. We cross it, fish it, dump into it, and skim its surface. But we do not know it. The fact that we've explored only 5% of it is not just a statistic. It is a mirror held up to humanity. It shows us the limits of our courage, the boundaries of our curiosity, and the persistence of our fear. Humans are creatures of air and light. We thrive in open spaces. In landscapes we can map and walk. The ocean denies us that comfort. It drowns us, blinds us, crushes us. To enter it we must wrap ourselves in machines. To survive it, we must fight against everything it is. No wonder we've avoided it. No wonder we look to the stars instead, dreaming of Mars while ignoring the abyss at our feet. But fear has consequences. By ignoring the ocean, we leave ourselves blind to its dangers and ignorant of its gifts. For all its terrors, the ocean sustains us. It generates most of the oxygen we breathe, not from forests, but from plankton floating in its sunlit surface. It regulates our climate, storing heat and carbon. It provides food for billions. It is the engine of life on this planet. And yet, we do not treat it as such. Pollution chokes its waters. Plastic drifts in gyres the size of countries. Carbon emissions warm its currents and acidify its chemistry. We threaten the very system we depend on, while knowing almost nothing about how it truly works. It is as if we are dismantling a machine while blindfolded, unaware of what each gear does, unaware of which one keeps us alive. At the same time, the ocean is not only provider, it is destroyer. Every disaster it unleashes, tsunamis, storms, floods, reminds us that it is bigger than us. We live on its edge, building cities where the land meets the tide, pretending the waves are tame. But history tells us otherwise. Civilizations have fallen to the ocean before. They will again. And perhaps in the 95% we have not explored, the seeds of the next catastrophe already wait. A shifting fault, a growing volcano, a fragile slope of sediment ready to collapse. The ocean hides its threats as well as its treasures. Perhaps the greatest terror and greatest wonder is what lives within it. We know only fragments of the story, creatures that glow, monsters of impossible size, microbes that rewrite our understanding of biology. And if such things exist in the slivers we've studied, what else waits in the dark? Maybe there are predators we have never met. Maybe there are ecosystems stranger than science fiction. Maybe there is even intelligence, shaped by pressures and darkness we cannot imagine. To dismiss such possibilities is to forget how wrong we've been before. The ocean humbles us. Every discovery proves we have seen nothing yet. Every myth reminds us we are not the first to sense this truth. To leave the ocean unexplored is to live in ignorance of our planet. But exploration is not just science, it is survival. To understand the ocean is to understand the system that sustains us, the forces that can destroy us, and the mysteries that define us. We fear what we cannot see, but fear is not safety. Fear is blindness, and the longer we leave 95% of the ocean in darkness, the more we gamble with our future. We tell ourselves stories of conquest. We scaled mountains, crossed deserts, mapped the continents, and even reached the moon. But these are margins. The true frontier is not above us. It is below. It is the abyss. And that abyss is not empty. It is alive. It is shifting. It is waiting. We have explored 5% of the ocean, 5 rooms in a library of 100, 5 pages in a book of 1,000, 5 breaths in a storm that has raged for billions of years. What waits in the rest? Monsters, catastrophes, civilizations lost, forces we do not yet understand. The truth is, we do not know. And that is the most terrifying fact of all, because the ocean is not background. The ocean is the planet, and we have barely dipped our toes.